So let us start with the algorithm to evaluate postfix expression. And here I have taken a infix expression, and that we will be converting to a postfix expression and use that for evaluating the postfix evaluation. So let us check how we will be doing it. So using the normal what we have been doing, so it will be equals to, if I write it down, 9 minus, so I have the first expression which is within brackets, 3 into 4, it will be 3, 4 plus 8 by 4. So using the normal way of manually converting it, so next will be the parenthesis which is left. So it will be 3, 4 into, and then we have the operand 8, so plus comes, and then we have the division 4. I think you are following it given the last part of my lecture where I have already discussed it. So now I have two operators, minus and division. So division is having more precedence over minus. So I will be first doing that part. So it will be 4. So it is between this 3, 4 star 8 plus and the 4. So these are the two parts. So one, for the division operator, one is this operand and the other is this. So I will here put the division after 4 and then the minus. So for the minus, what are the operands? So the operands are 9 and this whole part. So for this, it will go 9, 3, 4, star, 8, plus 4, divide, and then minus will come. So this is my ultimate postfix expression equivalent of this infix expression. And let me copy this. And this is what we are going to use for our evaluation part. So this is my expression. Now, what is the algorithm for evaluating a postfix expression? So the input will be naturally the postfix expression which I am having, and the result of the expression will be my output of this program. So what we do, so like the postfix expression, like in case of the infix to postfix conversion, so we have to mark where my expression evaluation, where my scanning is over, and that scanning I am doing with the help of the right parenthesis. So whenever in the expression evaluation or in the expression scanning we encounter a right parenthesis, we know that is the end of my expression. Now the same thing we will be scanning from left to right of this particular expression, of this postfix expression, and we will continue until we find a right parenthesis. Now students, here you remember that whenever we are evaluating a postfix expression doesn't contain any kind of parenthesis, because we have already removed that while converting from an infix to a postfix expression. Another thing is that when the computer system is evaluating this, it does not need to worry of the precedence of the operators as well as the associativity of the operators, because taking all that into consideration, only the infix expressions are converted to the postfix or the prefix notations. So it will be a simple evaluation from left to right, and as we encounter the operators, we will be doing the needful task. So what is the first task? If an operand is encountered, then push it onto the stack. So let us start scanning the characters. So my first character is 9. So when my first character is 9, so it belongs to the operand category. So in case of evaluating a postfix expression, the operands need to be pushed into the stack. So I will be pushing my 9 to stack. Then my next character is 3. So 3 is again an operand. So I will be again pushing it into stack. So 9. You can use a comma for separating out the contents of the stack, or you can use a space also. I am using a space. I am using a space for separating the elements. Next, the character which is there is 4, which is again an operand. So I can also write 9, 3, 4. Let me stop at this stage and let me show you what is the stack content right now. So this is my stack. And here at first I have pushed 9. Then I have pushed 3 in this stack. And then I have pushed 4 in this stack. So my top element right now is 4. So like the infix to postfix expression evaluation, in this case also the last element which we are showing, so this last element actually represents the top of the stack. Okay. After this we have the character star. Now star is no more an operand, so let us come to the operator part. So what does it telling if we encounter an operator here is that we pop the 2 elements, that is the first 2 elements of the stack. We will be popping the first 2 elements in the stack. So let us go to our stack content right now. So the first 2 elements is 4. So that is at the top of the stack, and the other one is 3. So let me write down. So this is 3 and this is 4. And what it is telling, we do a B operation A. That means so this is A, the top element is A, this is B, the next element in the stack, and we do B operation A. That means here the operation is multiplication, so we do 3 into 4. So 3 into 4, what it gives us? It gives us 2. So when we pop these 2 out of the stack, then these elements are no longer there. So the top moves from here and it goes to this place. So this is my top right now. And this is my B value and this is my A value. And once we evaluate, what we do, we push the result of B, this will be B operation A as the top element of the stack. So whatever evaluation we get, we put it back into the stack. So when we put it back into the stack, let me remove this part. So when we add 12, so the result of B operation A is put back into the stack. So then top moves in this location again. So when we come to the stack, so what we are having right now, we are having 9 and we are having 12. Then what is the next character which is scanned? The next character which is scanned is 8. So we put a 8. So it is again an operand. So what we do, we push it into the stack. So we are having 9, 12 and 8. So let me add 8 here. So this is my 8 and then my top is no longer in this place. Now my top moves where? My top moves to this. Now what is the next character scan? The next character scan is plus. So that is a operator. So whenever we encounter an operator, we pop the 2 elements, the top element and the next element from the stack. We operate B, operate A. and you put the result back into the stack. So in this case, what happens? So in this case, what happens is, the top two elements in the stack is 8. So this is my A, and 12. So I am having 8 and 12, and this is my B. So when I pop these two elements from the stack, these spaces becomes empty. Top no longer remains here. Top moves to this place. This is my top right now, because the two elements has been deleted. And this is my B, and this is my A. So we do B op A, and what is my operator? My operator is plus. So what is the result? The result is 20. So I put that result back into my stack. So pushing the result of B operation A back to the stack. Next, what do I get? I get a 4. So 4 is, so this will be B operation A. So you, there is a, this part you should be careful. So this is B operation A, okay. So what we are having another operand. So operand will be pushed into the stack. Now what is my operation? My operation is division. So now when my operation is division, let me redraw my stack here. So let me redraw my stack. So I'm having 3 elements, and those 3 elements are 9, 20, and 4. Now this is my A, and this is my B. So I put this element out, 4, and I put this element out, which is 20. So this is B, and this is A. So I do B op A. What is my operation? My operation is division. So 20 divided by 4 gives me a 5. And when this is happening, these two elements are no longer there, and top is pointing to this location right now. So this is my top. So this result is 5. So what I do, I put it back into my stack. So I write a 9 and I write a 5. After I have done this, so how do my stack looks like? So my stack now looks like this. Okay. So I am having 5 as my top element. So this is 5. So my top is pointing right here. Now what is the character? Last character which is scanned. Let us go back and check. Okay. So this is my character. What is that? Minus. So I have a minus. So if I have a minus here, so what is there in my stack? 9 and 5. So this is A. So I will be writing it here. So this is my A. And this is my B. So I do a B minus A because my operator is minus, and I get a 4. So what I do? I write a 4. Now what is, this is my last check. So once I do this, what happens? So my all the characters has been scanned. What is there at the last? So at the last I am having this symbol, which was the right parenthesis which we added at the beginning. So once we encounter this, what happens? The process stops. That means the whole expression has been evaluated and the result will be equals to the top element of the stack. So in our case, that value is 4. Now, we can try to do this same thing. So we have calculated that. So this is my value, which is 4. And I have found that using the evaluation algorithm for a postfix expression. Now let us find out, given this infix expression, if we normally do it in the way how we calculate the result from a given infix expression, do we get the same thing or not? So let us see. So I'm having 9 minus 3 into 4 plus 8 by 4. So which operation will take place first? So the operation which will take place first is this. So this is going to give me a 9 minus 12 plus 8 by 4. And then this operation is going to take place because it is within the parenthesis. So this is going to give me 9 minus 20 by 4. Again, the division operation will take place. So because of that, I will get a 9 minus 4. So the only operator left is minus. I will get a 4. So see, evaluating the postfix expression using stack and normally calculating the getting the result out of a infix expression evaluation gives me the same thing. And if you look at these values are same. See, we have got a 12 here. We have got a 8 here. So 12 plus 8 gives us a 20. We have got a 20 here. 12 by 4 gives us 5. We have got a 5 here. And ultimately, we have got this result to be 4. So this is the algorithm for calculating the result of a postfix expression. Now, there is one distinct point between algorithm for evaluating a postfix expression and algorithm for changing from an infix to a postfix. In case of the postfix expression, here the operands are pushed into the stack. Well, in case of the infix to a postfix expression conversion, operators were pushed into the stack. So you should remember this difference. If you remember this difference, it will be easy for you to write the algorithm on your own also, because there is not much difficulty in writing the algorithm if you understand the logic. So I hope this video have helped you in understanding some basic applications of stack. There are many more, such as conversion from an infix to a prefix expression, such as the evaluation of a prefix expression, and so on. So I think you can do that algorithm on your own. If you are having any doubt, you can always contact me. Thank you very much.